In this section, I'm going to go over how to solve equations and inequalities that have absolute value in them. I'm going to start with equations. So I'm going to go over a couple different kinds of equations, but I'm going to start with the most basic kind. So let's assume we have an equation that's of the form the absolute value of A equals P, where P is some positive number and A is some expression. Now when I say an expression, I mean it has a variable in it somewhere. And in this video, I'm going to use capital letters A, B to represent expressions with variables. And P is always going to mean a positive number, so P stands for positive. So for example, let's say we had the equation, the absolute value of 3x minus 1 equals 5. Now you see 5 is a positive number, and the thing inside the absolute value symbols is an expression with a variable, so that fits that form. Now anytime we have this kind of a setup, we want to realize that that's going to be equivalent to, and I'm going to use these double-sided arrows to mean equivalent to, that A equals negative P or A equals P. So in other words, we want to break this up into two separate equations. And we take the expression that's inside the absolute value symbols, 3x minus 1, and we'll set that equal to negative P, so negative 5. And then we'll take it again and set it equal to 5. That gives us two separate equations. Now we're going to solve these both separately, the way we normally would. So here we'll get 3x equals negative 4. And then we'll divide by 3. And so one solution will be x equals negative 4/3. And then we'll solve this other equation the same way. So we'll add 1 to both sides, so 3x equals 6. Then divide by 3, so x equals 2. And notice you'll get two solutions to an equation of this type. Now if you check this, if you plug in negative 4/3 in for x, you end up getting the equation, the absolute value of negative 5 equals 5, which is true. So that checks. And when you plug this other solution, x equals 2, in for x, you end up getting the absolute value of 5 equals 5, which is also true. So both solutions check. Now sometimes we'll have a problem that's not exactly in this form, the absolute value equals P, so we'll have to put it into that form first. For example, in this problem, notice the absolute value of t is not alone on the left side of the equation. So we want to start by getting the absolute value of t to be alone. So we'll add 4 to both sides. So that gives us 3 times the absolute value of t equals 15. And then we'll divide both sides by 3. So we get the absolute value of t equals 5. Now the equation is in this form, the absolute value of some expression. In this case, the expression is just t equals some positive number, and 5 is a positive number. So we know we can transform that into two separate equations. We take the expression that's inside the absolute value symbols, which is just t in this case, and set it equal to the negative of p and the positive of p. And usually we have to solve that out, but in this case there's nothing to solve, and so those would be our solutions. Alright, let's look at another example. This again is not quite in the form absolute value of A equals P, because to be in that form the absolute value has to be alone on one side of the equation. So the first thing we do is we divide both sides by 5 to get the absolute value part alone. So then we have the absolute value of 6x minus 5 equals 3. Now that it's in that correct form, we take the expression that's inside the absolute value symbols, the 6x minus 5, and we set it equal to negative 3, and then again we write it and set it equal to positive 3. And we solve these separately. So on this side we'll add 5 to both sides, so 6x equals 2, divide by 6. If we reduce that down, x equals 1/3. That would be one solution. And if we do the same process on the other side, we end up with x equals 8/6, which reduces down to 4/3. Now remember, you're getting two solutions to these kind of problems, because one of the solutions, the 1/3, when you plug that in for x, that makes the inside expression here come out to be -3. And so you end up with the absolute value of -3 equals 3, which is true. And the other solution, 4/3, makes the inside expression come out to be +3. And so you end up with the absolute value of 3 equals 3, which is also true. Now I want to go over a little different kind of problem, but it's similar but a little different. We still have the absolute value of some expression a on the left side of our equation, but now we have the absolute value of some other expression b on the right side. So we have two different expressions, meaning things that have a variable in them with inside absolute value symbols on both sides of the equation. And when we have that situation, this will be equivalent to, so again, this double arrow means equivalent to, meaning we can change it into that a equals -b or a equals b. So that's a similar process, but we're working with two expressions now, both inside absolute values. So here's an example of that kind of problem. Notice we have expression a being 5x minus 2, and expression b is 3x plus 6. And so we want to transform this equation into two separate equations. We're going to take the 5x minus 2, which is the inside part on the left of the equation, and set it equal to the negative of the right-hand expression. And the important thing is that you remember to put your parentheses in here. And then we want to do the similar thing. We want to take 5x minus 2 and set it equal to the positive of the inside expression on the right side, which is just 3x plus 6. Now, again, the tricky part here is remembering the negative with the parentheses, because that will distribute through there. It's like multiplying both of them by -1, which would give you 5x minus 2 equals -3x minus 6. And then you have to solve for x, so add 3x to both sides. And you'd also have to add 2 to both sides, which you could do in the same step. That would give you 8x equals -4, and then divide by 8 and reduce, so x equals -1/2. And that'd be one solution. Okay, we'll do a similar process for the other equation. We're going to have to solve for x there as well. So we'll subtract 3x and add 2 to both sides. That gives us 2x equals 8. Divide both sides by 2, so x equals 4. Now that we've gone over how to solve equations that have absolute value in them, I'd like to discuss inequalities. Now, inequalities, remember, will have a less than or a greater than or a less than or equal to or a greater than or equal to symbol in them. Now, with inequalities, it makes a big difference whether the symbol is a less than sign or a greater than sign. And so I'm going to discuss those two kinds of problems separately. Let's start with a less than or equal to symbol. So let's assume we had an inequality that was of the form the absolute value of some expression a. Now remember, a represents some expression with a variable in it, like x, is less than some positive number. And again, p is representing a positive number. Now whenever we have this situation, we're going to break that, meaning this is equivalent to breaking this down into a three-part inequality of the form -p is less than the expression a, which in turn is less than the positive number p. So this is the really crucial thing to remember, is that whenever you have an inequality that's in that form, you want to convert it to a three-part inequality of this type of form here. Now, before we do this example, let me just point out that this same situation would apply for a less than or equal to sign here. So if this was a less than or equal to symbol on this side, then when you change it to a three-part inequality, you would use a less than or equal to here as well as over here. Now, just like with equations, the first step is to get the absolute value by itself on one side of the equation. So I'm going to divide both sides by 7 to get the absolute value of 3x minus 2 to be by itself on the left side of the equation, and then 42 divided by 7 would be 6. So now that we have this inequality that's of this form, the absolute value of a is less than or equal to some positive number, we're going to turn that into a three-part inequality. Now notice when we do that, the negative number goes first on the far left. That would be negative 6. And then it's going to be less than or equal to whatever the expression a is, which in our case is 3x minus 2. It's important that you remove the absolute value symbols from it in this step. And then that's less than or equal to the positive number, which would be 6 in our case, on the far right side. And then to solve this, you want to try to get x by itself in the center. So this center part, 3x minus 2, you want to get that to be just x. So first you'd add 2 to all three sides, and that would give us negative 4 is less than or equal to 3x, which is less than or equal to 8. And then we'll divide all three sides by 3 to get x all by itself in the center. And that would give us a solution of negative 4/3 is less than or equal to x is less than or equal to 8/3. Now, this is one way to express our answer. This is called an inequality. And this basically means that any number between negative 4/3 and positive 8/3 would make the original inequality come out to be a true statement if you were to plug it in. Now there's two other ways you could express your answer. One is by graphing the solution set on a number line. To do this, you just graph a number line and plot the negative 4/3 on the left, because that's a smaller number, and positive 8/3 over here on the right, because that's a larger number, and you want to shade in between. And whether or not to include the two endpoints depends on whether there's equality or not in these symbols. In this case, there is equality, so you do want to include them. So you'll fill them in with solid dots. If you didn't want to include them, you'd leave open circles, just like we did before, and we'll shade between those 2 points. So any number in that shaded area makes the statement true. So that would be another way to express our answer. And that's called a graph on a number line. And the last way is by using an interval. And that's where we're going to use closed brackets because we are including the endpoints. We put the left endpoint in, negative 4/3, then a comma, then the right endpoint, 8/3, and then another square bracket. And that would be an interval. Now I'd like to go over how to solve an inequality that has a greater than symbol, or a greater than or equal to symbol. Now we have to approach these a little bit differently. We're still going to break this up, but this time we have to break it up into two separate inequalities. An inequality of this form is always going to be equivalent to, so here's our double-sided arrows again, meaning equivalent to, or meaning we can transform it into a, whatever that expression a is less than negative p, or a is greater than positive p. So again, this is the crucial thing to know, that if you see an inequality of this form, where you have the absolute value of some expression is greater than some positive number, you want to know that you can break it up into these two separate parts. A is less than negative p, or a is greater than positive p. And then you solve both of those parts separately and take the combined solution set for your final answer. So here's an example. We have the absolute value of some expression with a variable in it, the variable c in this case, is greater than the positive number 12. So what we want to do is take the expression that's inside the absolute value symbols, which is 4c minus 8, and set it less than the negative 12, or set it greater than the positive number, positive 12. And we're going to solve these two separate inequalities kind of like separate problems. So we'll get c alone on the left side of the equation. So in this first one, we'll add 8 to both sides, and that gives us 4c is less than, let's see, negative 12 plus 8 would be negative 4, and then divide by 4. So c is less than negative 1. And then we'll do a similar process for the other inequality. Add 8 to both sides. So 4c is greater than 20. Divide by 4. So c is greater than 5. And the word that would connect those would be the word or, meaning you're going to combine the two together. So that right there would be your inequality way of writing your answer, and you should include that word or in there, because again, that means that you're going to combine the two sets of numbers. So you're going to include all numbers less than negative 1 combined with all numbers greater than 5 for your overall solution set to this problem. Now if you were to graph this on a number line, again, you draw your number line with just a horizontal line, and then plot the negative 1 on there, and then plot the 5 on there. And you want to shade in numbers that are less than negative 1. Now that doesn't include negative 1, just less than negative 1. So you do a circle open and shade to the left like this. Put an arrow showing it keeps going. And you also want to include all numbers greater than 5. Again, that doesn't include 5, so you'd have a circle and shade to the right, because greater means to the right, and you'd put an arrow there. And that would be your graph. And then for your interval, you'd actually have to write two separate intervals, one for each side of this graph. So for the left side, you'd go from negative infinity to negative 1. And so you would write that with a parenthesis symbol and a negative infinity, and then a comma, and then a negative 1, and then another parenthesis symbol. And then to combine that with another interval, instead of the word or, when you write intervals, you usually use a union symbol, which really means the same as or. And then we'll write an interval for this other part of the graph. Now this will go from 5 up to infinity. So we'd have a parenthesis with a 5, comma, infinity, and then another parenthesis. And these would be, this is the way we'd write our answer using intervals. And like I said, you really need to write two separate intervals and use the union symbol to connect them together. I also want to talk briefly about equations or inequalities that have no solution. Now the key thing to remember here is that when you take the absolute value of anything, I don't care what it is, whether it's a number or an expression or whatever it is, you can't get a negative number. It always will come out to be greater than or equal to 0, but it can never be a negative number. So let's assume you had an equation that said that the absolute value of 3x minus 7 equals a negative number, like negative 8. Well, in this case, there'd be no solution to that problem. So you would just write that there's no solution. Or sometimes you could draw the empty set because the empty set means no solution, because it's empty. Another example would be, let's say you had the absolute value of 2x plus 5 is less than negative 2. Well, again, the absolute value of 2x plus 5 would have to be greater than or equal to 0. So it couldn't be less than a negative number. So again, that would have no solution. And you could either write no solution or you could draw the empty set indicating that. So you have to look out for those kind of problems and beware about that, because once in a while they'll show up. The last thing I'd like to go over in this lesson is how to solve an equation graphically. Now, to solve an equation graphically, we'll just take the left side of our equation and we'll enter it into y1 on our graphing calculator, and we'll take the right side of our equation and enter it into y2, and then we'll find the points of intersection, and the x-coordinates of those points of intersection would be the solutions. Now, we'll use our graphing calculator to do this, and the important thing to know is where to find the absolute value. So that's under the math key, and if you hit the math key and then you go over to the number, you'll see it's the very first option here, ABS. So you hit enter on that, and then you would put in the x plus 4, and then close the parentheses, and then plus 3, and then go down to y2 and enter in the right hand side of the equation. So that'd be 9 minus 2 times, and then again you'd have to go back to the math key and then over to number and absolute value of x plus 5. And then once you get both those entered in, you need to graph them. So I'll just hit zoom, and then I'll use standard, which is zoom 6. And notice the graphs with absolute values often come out V-shaped. So you have two V-shaped graphs, and we're looking for these points of intersection. Looks like there's 2 of them, and to find them we'll do the second trace, intersect, so number 5. And then for first curve we just hit enter, and second curve enter again. And for the guess we'll move it close to that point, and once we get it close we'll hit enter. And notice that the x-coordinate of that point is negative 2.67 if I round that off just a little bit. So that would be one of the solutions. And then we'll do second trace again and intersect, and again first curve hit enter, and second curve hit enter again. And then for the guess, go over closer to the other point now for the guess, and then hit enter again, and that'll show you that point. And we want the x-coordinate only for the solution, so negative 6.67 if I round those off. So notice there's 2 solutions, and they can be found by finding the points of intersection between the 2 sides of the equation. And you can solve any equation that way. We've done that before with other equations, and I just wanted to show you that you can apply this to equations that have absolute values in them as well.